Yeah, you can see the degree of freedom 1 and degree of freedom 2. So you have actually f has a 2 degree of freedom, and then this is about when alpha is 0, 0.1 and 0.05. This is what we use, and then our degree of freedom 1 is 3, and second degree of freedom is pretty big. So this is a third column, right? It's a 2.68. So our degree of freedom is like 350. So that's why the critical F. This is the 0.01 case. It's 3.78. So I thought that's okay. This is a 0.01, and third column. And if you go down like 120, this is 3.9. Well, infinity is 3.7. So our case degree of freedom is 350. Maybe it's between these two numbers. So that's why we got a 3.78. Okay, and then since our t statistics is 9.5, is way greater than 3.7, so probability is almost 0. So if null hypothesis is true, the probability that we can get our result is 0, which means our null hypothesis is we can reject the null hypothesis. So what we can conclude is three variables are jointly significant. Why I say this jointly significant? They are individually, they are not significant individually, but jointly they are significant. So the likely reason is a multi-collinearity. So we will talk about this a lot, and then the decision making, do I have to drop the variable or not? We will talk about that when we talk about the model selection. But here, this is a more like a hypothesis test. How can we say is it significant or not? But sometimes, even though the variables, our factors are individually not significant, but altogether they can be jointly significant. So we can reject null hypothesis, which is the beta 3 equals beta 4 equals beta 5 equals 0. Maybe one of them are significant, but not individually. It's not possible altogether. Only one of them are significant. If only one of them are significant, two of them are not significant, you have to have one is significant individually, but it's not. So they are not significant, each one of them, but jointly they are significant, which means they have a kind of effect on the salary. So if you want to use Excel, actually you have to calculate that things. Okay, so this is the linear restriction. I think the order is quite. You can just set. This is the typical F test, right? Everything is 0. None of the factor has an effect at all. So all of them are 0. That's a null hypothesis, and you can calculate it the same way because now if Q is K, because I'm including everybody here. Right, so we have a beta, beta 0 is a intercept. That's why we exclude the beta 0 here. What this means is none of the independent variable has a effect on this price. So that's why it's a beta 1. However, as you can see, this is a different. This is a 1. Our hypothesis, this is 1. Not all the zeros. right? Then what you can do is unrestricted regression is the including the everybody. Restricted regression is the assuming H0 is true. So which means you know the beta 1 previously, right? No, our null hypothesis beta 1 is 1. So we assume that this is a 1, right? And then we can do the same thing. We can calculate the 1. Yeah, how can we run the regression here? Can we force this one is 1? You cannot. So that's why you just move this one to back here. We consider this is our dependent variable, and then you don't use anything, right? And then you can calculate the SSR, or if you use R, you can just simply set the hypothesis. Which equals 1. So yeah, we can do this on the R. So I will show you how to do this in the R. Again, I'm going to bring the data, which is the H price 1 package equals, right? So we get a pH1, right? And then our model was, what was our restricted model? So log price. So I want to refer this one. So this is a H price linear model and log price log assess plus, what is the next one? Is log lot size plus log square feet SQR not T square feet and the bedroom bedroom BDRM, okay, plus BDRMS. Yeah, I forgot to indicate this is from the data equals H price 1. Okay, now we can look up the summary of H price. Not H price 1, is HP price. And you can see the result of the regression. And as you can see, this is about 1. And this is, they have a pretty small numbers, right? So that's why the null hypothesis is creating beta 1 is 0 and all other things 0. So what we can do is a null hypothesis. We can create a null hypothesis equals C, and then we can say beta 1 was a 1. So what is the beta 1? So log assess equal to 1, comma, and then we don't have to say 0. It's a log lot size, right? I don't have to make a equal 0. That's the default sqrft, comma bdrms. Okay, and then we can just simply put the linear hypothesis that h price, that's our model, the regression model, comma h0. Okay, so then you can see what is the linear hypothesis test. This first one is 1 and our other things is 0. And if you take a look at the probability here, it's about 60%. Wow. So which means we cannot reject the null hypothesis. There is a 60% chance if our null hypothesis is true. What is the probability that we can get our current result is the 60%. So yeah, maybe that just comes, even null hypothesis is true, but yeah, there is a high probability we can get our current result. So we cannot reject. So we don't have strong enough evidence to reject our null hypothesis. Okay, so what this means, H0 cannot be rejected. So result will be exactly the same. You don't have to actually calculate this t-test and so on.